Today we're going to still be in the inverse chapter on the matrices. Today we're going to talk about how to encode and decode messages. So the idea is this is important for computers. So when you, for example, when you buy something on your credit card at a website, they are going to encode and encrypt your credit card number so that it gets all scrambled up, and then wherever the information gets to where it needs to be, it'll be decoded. So obviously they have algorithms that will do that. This is in place to kind of prevent people from hacking onto their software and stealing your information. So the kind of process for encoding a message is whatever your message is, we're going to express it numerically. It's important that you list the numbers down by the column versus going across on the row. And then you're going to pick any 2x2 invertible matrix, and you're going to use this code, what we call coding matrix, and multiply that by your 2x2 message matrix. Your result is going to be the coded matrix. So this is something I would recommend taking a screenshot of or jotting down. So this is the alphabet with the numerical values next to all of them. 0 would imply a space, or if you have let's say it's a 3-letter word and you have an extra spot, you would fill it in with a 0 if you have extra space at the end. So I'm going to be referencing back to this today. So they want you to encode the word OLA. So first we need to find what numbers match. So I need HOLA. So H is 8, O is 15, L is 12, and A is 1. So next we're going to take this and we build our matrix with it, and we go down the column. So I would put my 8, 15, 12, 1. So this is my coding matrix off to the right. So this just means it's invertible. So the other day we discussed that not all 2x2 matrices have an inverse, or necessarily that it works out to be a nice inverse. So this would be an example of one that definitely works out well. So we're going to use that matrix. So I take my coding matrix first, and we times it by this message. And remember, we still do that whole row by column thing. So my coded matrix is going to be a 2x2. So again, I'm just going to do my scratch work off to the side. So here I have -2 times 8, which is -16, minus a 45, which is equal to 61. Then my next row by column, -2 times 12 is -24, plus a -3, which is a -27. That should be a -61, sorry. And then my next row by column, 3 times 8 is 24. 4 times 15 is 60. So here I get 84. And for that fourth spot, 3 times 12 is 36, plus 4 is 40. So this is what we call the coded matrix. So this is my coded matrix. So next we're going to discuss, well, once this coded matrix gets where it ever needs to be, how do I uncode it? So notice I jotted these numbers down, making sure I went down the column. So I went down the first column and my second column, and I wrote my numbers out. So in order to decode this message, I need to take my coding matrix and find the inverse of it. So my coding matrix was -2, -3, 3, 4. So we need to calculate the inverse of this. So remember, we do 1 over A times D, which is -8, minus B times C, which is -9. So here I'll get 1 over 1, which is just 1. And then remember, we swap them on the diagonal, and then the other two stay but change their sign. So this is my inverse matrix. So this is the inverse of the coding matrix. So if you don't have the original coding matrix, you'll never know what to find the inverse of, which means you can never unscramble these values. So now I take my inverse matrix and I'm timesing it by the result that we got from that last problem, and we're going to try to unscramble this and figure it out. Now obviously we know what it's supposed to be because we encoded it, so the idea is later on we could each encode a message and then we could swap it, and then with that coding matrix we'd be able to decode. So remember, we're again going row by column here. So I have a 4 times a negative 61, which is a negative 244, plus 3 times 84, which is 252. And when I subtract these, I get 8. Then I have 4 times 27, which is a negative 108, plus 3 times 40, which is 120. When I subtract them, I get 12. Negative 3 times a negative 61 is a positive 183. 2 times 84 is negative 168. And when I subtract these, I get 15. And lastly, I have 3 times 27, so that's a positive 81 minus 80, and I get a 1. And then remember, we go down the column, so I would go back to this original list, and I know 8 is H, 15 was O, 12 was L, and 1 is A. So again, we get that message of hola. So we're going to do some practice of this tomorrow. Obviously, we're going to have to kind of coordinate, and then we'll be able to kind of swap messages amongst our peers.